In this video, we'll discuss the qcCheck program. This is the program that launches, this is the window of the program that launches when you open up qcCheck from your shortcut menu. qcCheck needs to be run in order to reanalyze a CLR file. This is a calibrated luminance response file. That's the text file that's generated after you do a qcCheck as part of the lum response program. Whenever you save that CLR file within lum response, it'll ask if you'd like to plot the data. That plotting is actually calling the qcCheck program, and it'll automatically save 4 plots and an HTML file in the directory with the CLR file as part of the lum response program. If, however, the CLR file becomes orphaned or you don't choose to plot it as part of that routine, this is a way to regenerate those plots. Here's a directory with a CLR file as well as the files that are generated as part of this qcCheck routine. So I'm really just going to overwrite all of these here shortly using the same CLR file. So we launched the qcCheck to reanalyze our CLR. We need to select or type in the L ambient that we're interested in using as part of this room to check the LUT and make sure it was using the correct L ambient when it was generated. So for a darker reading room, we'll assume a 0.1 candela per meter squared L ambient. I'll click on Get CLR file name. It'll verify that you're using the correct phase file. In this case, I'm using the 16phase.txt file. That's the same one that's loaded as part of the standard distribution. So I'll click Yes to continue. And you can see here that my directory is the same one that's listed at the top here. So I'll select the CLR file, and open that. And it's going to start running through that same plotting routine that if you run the lum response program and save the file, you'll see the same plots. So here's a luminance plot. It gives the file name at the top with the model the model of the monitor you're using, the serial number, anything you've typed on to append this. Here I was operating at a specific white point of the monitor, and I'm running the 16qc file, as well as the date. I have some information about the test, the maximum relative error that it calculated, as well as the L prime max, L prime min, and the luminance ratio. Here you can see the red dots are measurement points, and the green line is the DICOM GSDF. This monitor is obviously well calibrated to that curve. We'll click OK to proceed through the plots. Next, we see the contrast per JND, again following very nicely over that DICOM curve, and the inner lines, dotted lines, are 10% deviation from that, and the outer lines are 20%. Again, up here, you can see that at the legend of the curve. 5.4% is at the 16th point, which it looks like is here, or 5% off the DICOM. That's well within the limits for a primary display. Next, you can see the JNDs per gray level. For the DICOM GSDF, you should have about an equal number of JNDs for each gray step, and so this line should be flat, and you can see that's very close to the case here. And finally, we get the a color performance plot. The center of this plot is the D65 point using the 2-degree observer, and you've got radii at both 0.01 and 0.02. We like to operate within 0.01 for primary displays and 0.02 for secondary displays. The plotting of the points is very clustered for this specific monitor. That means you have a relatively uniform gray point, a white point throughout the grayscale. If you have something that doesn't track particularly well with color, you might see a line kind of moving around on this plot. And it'll plot in gray with gray dots for gray levels below 128 and in black for gray levels above 128. So you can see here it starts about there and ends about there, all very close to our D65 point. It does not plot points below 5 candela per meter squared, and that's because the color differences don't matter so much at those really dark levels. We'll click OK again, and we're all done. And if you were paying attention, you might see that the files have now updated to the current time on my desktop, and it's generated those 4 plots, as well as a qCLR file. This is a parsed version of the raw CLR file, which looks like this. And this gives us something that looks kind of like the output of a TG18 standard QC test, where you have gray levels at 0, 8, 24, so on through 255. And then you've got your L prime average, the corresponding L of the GSDF, and then you've got some information that it uses to plot. And so your UV error, your different DICOM curves, how far you are from DICOM, that sort of thing, as well as some information about the testing. The last thing you see here is an HTML file, And this HTML file launch in the browser here, carrier, is going to be a way to quickly upload something to a web database, which is what we use at Henry Ford Hospital, where you can see you've got your display ID. This is what you type into the box in LumResponse, the date of the test, the time, and the LumResponse version. It has a tabular summary of all of the relevant information, the measured luminances and ratios, as well as your errors, your mean JNDs per grade level, as well as your error for the color. It also bakes in the image files into the HTML. These aren't links to those files, and this means that this HTML file can stand alone. And so if you were to look at the code for the HTML file, you'd see that the image file is coded in here, so you don't need to carry around all of the files if you wanted to upload the HTML. It can stand alone as it is, just like this. And it's a relatively small file, just 59 kilobytes for a single file. Close this out, and that's it for the qcCheck. You shouldn't need to run this program unless you have one of these orphaned CLR files or you chose not to run the plot routine as part of the LumResponse qcCheck.